Well, here we are again. Gotta pull up my calculator. What are the chances? Do you think my kids are going to bother us today? It's their last chance to do so. You might probably be able to hear my son screaming in the distance. He and my husband are playing video games. So, we'll see how long that lasts. Okay, so as a reminder, once again, you can post any questions you have on Schoology, and then I will answer your questions. Okay, here we go. Number 1 is A like apple, 2 is J like jelly, 3 is B like boy, 4 is J like jelly, 5 is C like cat, 6 is G like giant, 7 is B like boy, 8 is F like fox, 9 is E like elephant, 10 is J like jelly, 11 is B like boy, 12 is J like jelly, 13 is D like dog, 14 is G like giant, and 15 is A like apple. Now, before I get going on this one, you should know that there's only like a little bit of this test you can do if you went through Algebra 2. Until you get to advanced math is when most of this stuff comes up. So there are going to be a few things here, especially the last couple problems, that I'm going to kind of rush through. Because if you've never learned that math, well, you shouldn't really be getting these problems right in the first place. Like, this is the part of the ACT that is just a little bit beyond you. But if you've taken advanced math or pre-calculus or trigonometry, whatever it's called in your school, if you're from a different school, then you'll be able to do this. And if you haven't taken those classes, you shouldn't be able to do this yet, except for maybe some of the basic SOHCAHTOA stuff, depending on if you learned that in Algebra 1 or Algebra 2. Okay, so speaking of SOHCAHTOA, SOHCAHTOA. S stands for sine. C stands for cosine. These are trigonometric operations on your calculator. They are relationships between sides in a right triangle, essentially. O stands for opposite. H stands for hypotenuse. A stands for adjacent. So this one is opposite divided by hypotenuse. This one's adjacent divided by hypotenuse. This one is opposite divided by adjacent. And the opposite and adjacent parts are just sides of the triangle, so is the hypotenuse. The hypotenuse is really easy to find. It's always that diagonal one across from the right angle. And the opposite and adjacent sides depend on which angle you're focusing on. So we're focusing on this angle right here, this theta. And we're trying to figure out what that one is and that one is. So this one, since that's the angle we care about, this is the opposite side over here, and adjacent is, that word means right next to, so it's right next to the angle. Alright, so in the right triangle shown below, if tangent equals 3 divided by the square root of 55. So tangent is opposite over adjacent, so I know that the opposite side is 3, and the adjacent side is the square root of 55. So I'm going to write those in. Looks like 30, doesn't it? Okay. And then we don't know this side, and we're trying to figure out sine, so we need opposite and hypotenuse. So we need to find that side, which again is a squared plus b squared equals c squared, everybody's favorite theorem. So the a, we can maybe pick this one, that would be 3 squared, and then b is the square root of 55 squared, and then c is just c because we don't know it yet, so that's 9 plus a square and a square root, cancel each other out, so that's plus 55, equals c squared, that is 64 equals c squared, which means that final side, if you take a square root of both, is 8. Technically, the square root of 64 is 8 and negative 8, but in this case, since we're talking about a physical triangle, it has to just be the positive one. Okay, so now, to figure out sine, we have to take opposite over hypotenuse, SOHCAHTOA. As in, if you're hurt, you hurt your toe, maybe you need to SOHCAHTOA. Okay? So the opposite is 3, and the hypotenuse is 8, so the answer is 3/8, A. Alright, number 2. In the right triangle shown below, sine equals 4/13, then what's the cosine of theta? This is almost exactly like the last problem we did. We need to know the following things for so. We need to know that this is the opposite and the hypotenuse. And for cosine, ka, we know we need the adjacent and the hypotenuse. We're just going to fill stuff in and figure it out again. So the opposite from this angle is 4. That's over here. The h, the hypotenuse from this angle, is over here, and we don't know this one. So now I'm going to use a squared plus b squared equals c squared. That is 4 squared plus b squared equals 13 squared. Notice that on the first one, up here, the c was the variable we didn't know because we didn't know the hypotenuse. But in this one, since we don't know one of just the sides of the triangle here, the legs of the triangle, that's why there is a variable right there. So this is 16 plus b squared equals 169 minus 16 on both sides. So b squared is 153, and then you take the square root of that. Now, if you look over here, you can see that none of these have the square root of 153 involved, so that must mean that we can break it apart. So if you start dividing things in your phone, you find out that 153 has the perfect square 9 and just the number 17. So if you take 9 times 17, you would get 153. I know that the square root of 9 is 3. So technically this side here is 3 times the square root of 17. And 17 being a prime number, doesn't have a perfect square, definitely. So cosine is opposite over hypotenuse. Sorry, adjacent over hypotenuse, so that would be 3 square roots of 17. This is the adjacent side. Here's the hypotenuse. And then over 13, which is j. All right. These problems take a while. All right, we're going to do it one more time. Here we go. In the right triangle shown below, if cosine is 2/3, this will give you lots of practice with this. Ka, and we also need toa. So this is adjacent, this is hypotenuse. Adjacent is right here, that's 2, 3, this is h, this is a. We don't know what the side opposite is yet. So a squared plus b squared equals c squared. That's a squared plus 2 squared equals 3 squared. A squared plus 4 equals 9. And then minus 4 from both sides. A squared equals 5 square root, square root. A is the square root of 5. Okay. So I suppose it was kind of a bad move for me to call both of these a, but this is the adjacent side, and this is just the variable a in the Pythagorean theorem. So actually over here is the square root of 55, and we need toa, so we need opposite over adjacent, so the square root of 55 over 2. Oh, 55, I don't know where that came from. The square root of 5 over 2, which is b. Okay. All right, so now we're starting to get into a little bit of advanced math here. So if you've taken this course, then go with me, and if you haven't, I'm sorry that this is about to not make a lot of sense. So this is 0 to 90. This is a unit circle. It goes from 0 degrees to 90 degrees, down to 180, 270, and then back to 0 degrees. And it's a relationship between the cosine and the sine, making this circle basically right here. The cosine is x values, and the sine is y values. So the cosine is x values, and the sine is y values. Again, this is not going to make sense to you if you haven't taken advanced math, so you might want to skip this problem until that class, or you can try to keep up. One of the most basic trigonometric equations, or is basically this sine squared plus cosine squared equals 1. That's always true no matter what. And this part, this 0 to 90 degrees, all it tells you is that we're in this first quadrant right here, between 0 and 90 degrees, and that cosine and sine are both positive there, because that's also where x and y are both positive. So basically at the end, when you do a square root, you can definitely say the answer is positive. So we're just going to write down the identity that they gave us. And then if cosine of theta is 1/2, now notice I'm going to replace all of cosine of theta, not just the theta part. The cosine goes as well. So this is sine squared theta, and that square, by the way, if you're thinking why is it there, it's just like that's just, I don't know, not a rule, but something that just always happens in math where they just kind of everybody decided that we were going to write it that way so that it wasn't confusing. Basically, you're saying the sine is the thing that's squaring and the theta is the thing that's in the sine. So this is cosine theta, which is 1/2, but then we have to square it because it is cosine squared. That makes 1. So now we've got sine squared theta plus 1/4. The square goes to both of them, equals 1. If I subtract it from both sides, I get sine squared theta equals 3/4. And then to get rid of the square, I'm going to do a square root on both sides. Remember, that's the top and the bottom. So it's the square root of 3 over the square root of 4, which is 2. So J. We've been talking for so long, we're only on problem 5. These problems take crazy long time to do. In the figure, sine of theta is what? Okay.